Hello and welcome guys. Now in this video we will be learning about feature selection, why it is important for us. So feature selection is a process of selecting a subset of relevant features, or you can say variables and predictor, for use in the model building. So there are several reasons why feature selection is important. Okay, so the first is reducing overfitting. So when we use a large number of features to build a model, it can lead to overfitting. Overfitting happen when a model performs well on training data but fail to generalize to new data. So by selecting subset of relevant feature, we can reduce the complexity of the model and avoid overfitting. Just imagine using 200 features for building a linear regression model. So it will be very hard for each of the feature to do the uh, relationship finding between all of them, and just imagine how hard it will be to interpret each of the features, how relevant they are. So again, so this is why feature selection is needed. Another reason is improving model performance. So selecting a subset of relevant feature can also improve the model of the performance of the model. So when we include irrelevant or redundant features, they can add noise to the data and decrease the accuracy of the model. So by selecting only the most important features, we can improve the accuracy and the efficiency of the model. Third reason is reducing data acquisition and processing cost. Now, collecting and pre-processing large amount of data can be costly and time consuming. So by selecting a subset of relevant feature, we can reduce the amount of data we need to collect and process, thus saving time and resources. So for example, let's say we have a data set of 100 features that we want to use it to predict whether a customer will buy a product or not. Some of the features might include the customer age, income, gender features, as well as education features, level, then occupation, etc. So some of these features might be important than other in predicting the outcome. For instance, age and income might be more predictive than occupation or education level. So by using a feature selection method, we can identify the most important feature and only those in our model, include only those in our model. So this can help us build a more accurate and efficient model while also saving time and resources. So one more example, let's say um, suppose we have a data containing information about house, including the size of house, the number of bedroom, bathroom, location, and the price. So we want this data to predict the price of house given its feature. However, we will notice that there are some features that may not be relevant to price prediction, such as color of the house or the uh, other appliances at the house. So these irrelevant features can introduce noise into our model and make it harder to find the true relationship between relevant feature and the price. Furthermore, having too many features can also cause overfitting, where the model becomes too complex and fit the training data too closely, leading it to poor performance on new unseen data. Therefore, we need to select the most important and relevant feature that will help us make accurate predictions. We can use feature selection method to identify most informative feature and remove the irrelevant ones, which can improve the performance and interpretability of the model. So now, what are the different methods? So you can see there are multiple methods that we can go with. So let's understand one by one. So there is one filter method. So these methods use statistical technique to score relevant that is relevancy of the features. The most common features measures are chi-square, mutual information, correlation, and ANOVA features. So we'll see ANOVA feature in the later video, but we have understood correlation. But there are also others, chi-square, mutual information. So these methods are computationally efficient and can be used as a pre-processing step. Next we have a wrapper method. So this method train a model using different subset of features and evaluate the performance of each model. So the most common technique are forward selection, backward selection, and recursive feature elimination. So these methods are computationally expensive but provide a more accurate estimate of feature importance, since we have to train the model. Next is embedded model, or you can say embedded methods. So these methods incorporate feature selection into a model training process, including lasso, ridge, and elastic net. So moreover, we'll learn this about this during optimization phase in the later part. So these methods are computationally efficient but can produce expensive cost, as well as these models are improves generalization performance. So that's why these embedded methods are widely used nowadays. Next is principal component analysis. So this is algorithm also. So basically this PCA is a linear transformation technique that reduces the dimensionality of the data while retaining most of the variance in the data. So PCA can be used as a feature selection technique by selecting the principal component that explains the most variance in the data. Next is independent component analysis, or you can say ICA. So it's a blind source separation technique that extract independent source for a maximum number of signals. So ICA can be used as feature selection technique by selecting the independent component that are more, or you can say most relevant to the problem. Then we have random forest feature importance. So this random forest is a tree-based assembled learning algorithm that can be used to estimate the importance of feature also. So the importance of feature is measured by decreasing inaccuracy of our model when the feature is randomly permuted. So we will see more in detail since this is a very important algorithm. So we'll see a very mathematical intuition as well as implementation also in upcoming videos. Lastly, we have genetic and algorithm. So genetic algorithm are optimization technique that mimic the process of natural selection. So this algorithm can be used to search for a optimal subset of feature that maximize the performance of the model. So you remember I was talking about some wrapper method. So let's implement those wrapper methods. So wrapper method, I mean I will be implementing all of these here that you see, but first let's start with wrapper method. So wrapper method have uh, forward selection. So what forward selection is saying, forward selection is an iterative process which begin with an empty set of features. After each iteration it keep on adding a feature and evaluate the performance to check whether it is improving performance or not. So the process continue until addition of new variable feature does not improve the performance of the model. So this is forward selection. Now what backwards elimination says, backward elimination method is also an iterative approach, but it is the opposite of forward selection. The technique begin the process by considering all feature and remove the least significant features. So this elimination process continue until removing the feature does not improve the performance of model. Then we have exhaustive feature selection. So exhaustive feature selection is one of the best feature selection method which evaluate each feature set as brute force. So it means that the feature tries and make each possible combination of feature and return the best performance feature set. Then we have recursive feature elimination. So recursive feature elimination is a greedy optimization approach where features are selected by recursively taking a smaller and smaller subset of feature, and then as estimator is trained with each set of features, and importance of each feature is determined using coefficient attribute or through a feature importance attribute. Lastly, that we will learn, I mean in the upcoming videos, regularization. So this add a penalty term to different parameter of machine learning model for avoiding overfitting in the model. So this penalty term is added to the coefficient, hence it shrinks some coefficient to 0. Those feature with 0 coefficient can be removed from dataset. So these type of regularization are called L1 regularization, that is lasso, and then L2 regularization, that is rage, which is used for such purposes. And then one more important technique, that is random forest feature importance. So this is like a it's a type of bagging algorithm that aggregate a different number of decision tree. It automatically rank the nodes by their performance or decrease in the impurity over all the trees. So the nodes are arranged as per impurity value, and thus it allow to prune trees below a specific node. So the remaining nodes creates a subset of most important feature, and that is what we will be using for our modeling. So this is what random forest feature importance is. Now we have learned, I mean majorly all the feature selection methods. Now let's implement each of them moving forward, so to get an understanding of how the implementation is done. Okay, so most of the importance features like random forest feature importance, I will be showing it when we will be implementing the algorithm. Same thing PCA, same ICA, and wrapper methods. Wrapper method will start right after this video. Embedded method, which is regularization method, we will be doing same as when we will going through all the algorithms like L1 L2 algorithms. Okay, so hope it is clear. Let's move to the implementation part. Let's create a notebook. Okay, so the very first thing we will be doing is we'll import all the libraries, and then we'll create a synthetic data using make regression function. Okay, and then we'll implement all the four wrapper method that we have discussed in the previous video. Okay, so first let's import all the libraries. Then from sklearn, for creating data sets, we'll import the make regression function. Okay, feature selection, select k best comma f regression, then from iter tools, port combinations. Also one more library that we have to install, which is not pre-installed in Python, that is pip install mlx stand. So it need to be installed for using it. So from mlx stand, here also we have feature selection. Yeah, feature selection, import sequential feature selector. Okay, so now we have what it is saying, feature. Okay, it should be feature selection. So now we have imported all the library that we will be needing. Now let's create a synthetic data. Okay, you can also create this type of data to practice different type of problem statement. So make regression, here you need to pass what is the number of samples you need. So let's say 1000 data points. Now you have also another parameter, that is number of features. Let's say I am using 10 features. Then you have another parameter, that is noise. So how much noise you want to give. So let's say 30% noise, and then random state, let's say 0. Okay, now if you want to see x, which will look like the sorry, it is array, so it will look like this, okay. So now now let's implement the forward selection first. Okay, selection method. So let's create some space. Yep. Okay, so we'll for storing a feature list, let's create a list, best features forward. Then model we will be using is linear regression. Okay, now we'll run a loop. Okay, for underscore in the range of x dot shape, all the features basically. Okay, best score equal to 0, best features equal to none for now. For features in range of all the column dot shape of 1, if feature in best feature, so we'll check if it is already in our best feature list, then continue, otherwise selected features equal to best features forward plus that feature. Okay, now we'll create another variable, x subset equal to all of selected features. Now we'll fit the model with that subset of features and the target. Okay, so score equal to model dot score or x subset and y. If a score is greater than best feature, or you can say best score, we'll update the best score. Okay, equal to score, and best feature equal to feature. and then we'll append the best feature. Okay, best feature forward equal to, oh sorry, append, dot append best feature. Okay, so we have completed one of the feature importance method, that is forward selection method. Now let's print it. Okay, print forward selection best features. We can do also one thing, we can set threshold also. If a given feature I mean, if a list of given features cross the 50% threshold, then include that features to be best feature forward. Okay, but you can do all those testing. So you can see that, I mean, particularly this, it's saying all the features are important. So okay, so this is the basics, almost basic one, the basics of selection method. So it doesn't mean that it is wrong. It can be true that all the features are important, all the features are correlating with each other. Okay, so let's try out the second one. Okay, second is backward elimination. Okay, same way we will be doing it. So selected feature equal to list of range of x dot shape of 1, model equal to linear regression. Then we'll use while loop here. Okay, while length of selected features greater than 1, worst score equal to 1. By default we are setting our worst score to be 1. Okay, now feature equal to none. Now for features, in selected features, let's create the subset equal to selected features dot copy. Now subset dot remove feature. Now x subset equal to x all of the subset. Now we'll fit the model with those features, those subset feature. Model dot fit x subset and target feature. Now we'll store the score, model dot score with x subset and y, and we'll compare the score. If score less than worst score, we'll update the worst score. Selected features, that will remove the worst feature. You can see, right, I mean, we have stored all the features for now, and we'll keep on removing which is not important. Worst feature. Okay, now what we will do, we'll print. Okay, print backward elimination best features selected features. Okay, this one. Now let's run it. It's saying some comma error. Okay, yeah, you can see that for now in this method it is saying that 7th feature is the most important feature. Okay, let's move to the recursive feature elimination method. Okay, so recursive feature elimination method is like a very simplest implementation. Let's name it RFE. Okay, so here what we'll do, RFE equal to sequential feature selector, we have to pass our model number of feature, like k features. Okay, let's say we want 1 for now. Now forward equal to false. RFE dot fit our x comma y, then best features RFE equal to list of RFE dot k features idx. Okay, so now let's print all this. Best features, now let's print it. So this one is saying that the third column is the most important feature. Now let's say I want not just one best feature, but let's say I want 5 best features. Okay, so here in the k features you just name you know, you can give number of feature you want. Okay, and it will give you all the top 5 feature that is important according to RFE method. Okay, now lastly we have exhaustive feature selection. So let's see that implementation as well. Exhaustive feature selection. Okay, now let's create few list. Best score exhaustive equal to 0 for now, then best feature exhaustive equal to none, model equal to again same, linear regression. You can try out with other algorithms also. You will see that other algorithm will give you other numbers as possible, but you need to make sure that whenever you using these type of method, you use your basic intuition also, like basic understanding about the feature also. You will see that in some time in the when using real-time data, you will see that when these features, some of this method will tell you that X feature is not important, but that doesn't mean it is not important. It can be important. So make sure you don't just trust all these mathematical features. You have to use your brain also during selecting all the feature, because sometimes it won't give you right number that this feature is not important. But if you encounter with such case, make sure you check the variability, other different type of things, like mean, median, modes, then these type of thing, it will help you understand the feature deeply, and then make decision based on that, not just these type of feature you use for just selecting the feature. You will see, in future definitely that some of the feature is saying it is not important, but definitely if you know the data personally, you will understand, okay, no, this method is saying wrong, and you will see that. Okay, so make sure you remember that 4k in range 1 comma x dot shape of 1, comma k. Now we'll create a subset all up to subset, then model dot fit x subset comma y, then we will create a score equal to model dot score x subset score is greater than best score exhaustive, then we'll update our best score exhaustive equal to score and best feature list equal to subset. Now let's print all this feature which is important. Positive feature selection, best features. Now let's run it. Okay, it says double equal to, okay, comma. Okay, now you can see exhaustive feature selection method also saying that all the feature is important. Okay, so hope you guys have learned how to implement all this feature selection method, and see you in next tutorial. Thank you guys for joining.